algebra. We are on lesson 9.3, solving quadratic equations by using square roots. Our essential question today is, how do you solve quadratic equations by using square roots? This is going to harken back a little bit to chapter 1 even. So you're going to feel like you're in September again, a little bit, because we're really just solving an equation and we have one extra step with it, okay? So square roots. Remember, when you solve the equation, it means that you are looking for the solution for x, looking for those x-intercepts, finding the zeros. All of those are different ways of saying it. Using square roots is just one other method. And we can only use it sometimes, not all the time, but sometimes. Remember, with square roots, we always have two answers. Underline that, star it, highlight it, do something with it on your page. I want to remind you that you know about square numbers. Square root of 1 is 1. But remember, it's not just 1, it's also negative 1. So I usually write this plus or minus 1 on there. So take a minute, copy this table down, write it down for yourself, unless you feel really confident that you know all of these, which is great if you do. But make sure you have this down. And then we're going to do a couple of example problems. All right, let's do some examples. So I'm going to do the first two. So we've got x squared equals 16. We're going to square root our x squared and our 16 because the square root of x squared, those cancel each other out basically, right? And we're left with just x. Ooh, that looks like the x is canceled. It's just the squared that's canceled though. So we're left with just x. The square root of 16, if I look up here, it says it's positive 4 and negative 4, or plus or minus 4. So that is our answer, plus or minus 4. Let's take a look at x squared equals negative 4. Wait a second. If we square root both sides, the squared and the square root cancel each other out, but we can't take the square root of a negative. We cannot take the square root of a negative. When you get into Algebra 2, they will talk about a special annotation that we have for that when that situation happens. I'm just going to tell you for Algebra 1, we can't do it. It's not possible. All right, it's not possible. So the answer for this one is no real solution. For those of you who have heard of imaginary numbers, we've talked about them before, but that's what a square root of a negative is imaginary. So just write down no real solution. That's all you have to do when you see that. So you'll notice there are lots more problems on this page. Pause the video, try them out. See what they equal. Pause the video. All right, you should have gotten x equals plus or minus 11, x equals 0. It only has 1, not plus or minus, right? Because 0 is just 0. No real solution. X equals plus or minus 15, x equals plus or minus 7. No real solution, and x equals plus or minus 6. Let's turn over to the next page, all right? Let's turn over to the next page. So, with these questions on here, we're going to solve using square roots. I want to remind you about PEMDAS, all right? PEMDAS is parentheses, exponents, multiply or divide, add or subtract. We're doing it in reverse though. Right? We want to get the x squared by itself before we solve. We're going to do the first three together, and then I'm going to have you practice some on your own. To get x squared by itself, I am adding 5. What's the opposite of adding 5? Subtracting 5. So I subtract 5 from both sides. We get x squared, these guys are gone, equals 5 minus 5 is 0. Well, we have to square root our x and we square root our 0, so we get x equals plus or minus 0, which is silly because 0 is just 0. So our first one is x equals 0. For our second one here, I need to get x squared by itself. So first thing, I add 25 on both sides. So we have 4x squared is equal to 25. Then I need to divide by 4 on both sides. So we have x squared is equal to 25 divided by 4. Now I have to square root. Well, we know the square root of x squared is just x. with this one, I can do the square root of 25 over the square root of 4. We've been practicing that. That's what all of lesson 9.1 was, right? So the square root of 25 we know is 5, and the square root of 4 is 2. Another way of saying that would be plus or minus 2.5. Remember, when we take a square root, we have to have a plus or a minus. Let's take a look at this one here. It's a little different. We have x plus 2 squared equals 9. We actually have our squared by itself. All right, we have our squared by itself. So when I say we need to get x squared by itself, it can also be x plus 2 squared. We just want to have this squared on its own side of the equation. And here's why. Once I have the squared by itself, I can square root on both sides. So I know that I'm going to get x plus 2 equals plus or minus 3. So this is where we have to play the what if game, is what I call it. All right, the what if game. We have to say, well, what if it really is a positive 3 that we get out? What if it's a positive? So I subtract 2 on both sides, and I get an x equals 1. But what if this 3 is actually a negative? What if? So we have x plus 2 equals a negative 3. Well, I subtract 2 on both sides, and I get an x equals negative 5. So these are our solutions, x equals 1 or x equals negative 5. Those are our solutions. Remember, with this one, we had 2 solutions as well. It was just positive 5 halves and negative 5 halves. This one, we have 2 different numbers, positive 1 and negative 5. So try the PEMDAS, use PEMDAS, solve the rest of these on this page. Solve the rest of them on this page. Pause the video, try it out. All right, you should have gotten no real solution for the middle left because we cannot have negative 49, square root negative 49. Just not possible. For our middle, you should have gotten x equals plus or minus 5. For our far right, you should have gotten x equals 21 and x equals negative 11. For the bottom left, you should have gotten plus or minus 5/9. For the bottom middle, you should have gotten no real solution. We cannot have the square root of negative 64. When you get to algebra 2, you'll have fun with it, but not right now. And then with our bottom right, you should have gotten x equals 11 and x equals negative 5. Let's take a look at some more. All right, I'm going to do this top right one. I want you to practice the rest. So let's do the top right together. I want to get our x squared by itself. So the first thing I need to do is subtract 11 on both sides. So we have negative 5x squared equals positive 5. Next, I need to divide by negative 5. Divide by negative 5. So we have x squared is equal to negative 1. Wait a second. If I try square rooting that, the square root and the squared will cancel out, but I can't square root a negative number. So this is no real solution. No real solution. All right, there are 8 more on this page. Pause the video here, try them out. Pause the video here, try them out. For our top left, you should have gotten x equals plus or minus 3. For our top middle, you should have gotten x equals 0. For our left middle, you should have gotten no real solutions. We can't square root a negative. For the middle, you should have gotten x equals 0. For the middle right, you should have gotten x equals 6 and x equals negative 4. For the bottom left, you should have gotten x equals negative 7. There's only one because the square root of 0 is just 0. Right? The square root of 0 is just 0. For our middle one, you should have gotten x equals 9 halves and x equals 3 halves. And then for the bottom right, you should have gotten x equals 5 halves or x equals negative 7 halves. For the next part, you will want a calculator, okay? You will want a calculator. These are not going to come out as pretty numbers. The next part, grab a calculator or pull up Desmos. Desmos will work just fine for you. So for our next ones, we are going to end up having to round some of these, all right? They are not going to turn out very pretty for us. And that is okay, but I just want us aware that they're not going to be pretty. They're just not. So, for our first one right here, I don't like dealing with negatives, so to solve this one, I am actually going to add my 2x squared to both sides. Because then these guys are gone, and I am left with 2x squared equals 80. I can divide by 2 on both sides, so I have x squared equals 40. Then I need to square root, so I get x equals plus or minus the square root of 40. Now I can reduce this radical, and in geometry, I'm going to tell you over and over and over again, reduce the radical, don't give me the decimal. Reduce the radical, don't give me the decimal. So when we do that, we would get plus or minus, 40 is really 2 times 20, 20 is really 2 times 10, 10 is really 2 times 5. I see if anyone can escape. Yes, they can. We have a 2 who can escape, and 2 times 5 is left over, so that's 10. So this is really plus or minus 2 root 10. The decimal for it is plus or minus 6.324, all right? That's the decimal. Hundredths, all right? When we use a calculator, the hundredths, we want, actually this should say thousands. Yeah, it should say thousands. We want 4 decimal places, all right? 4 decimals. Go with 4 decimals when you are rounding, okay? 4 decimals. I want you to try the rest of this page on your own. Try the rest of this page on your own. All right, you should have gotten x equals plus or minus 9.4868. X equals plus or minus 5.6568. Our middle left is no real solutions. Can't do a negative yet. X equals plus or minus 5.1961 for your middle. For your middle right, x equals plus or minus 7.7459. For your bottom left, you should have gotten x equals plus or minus 4.472. For the bottom middle, you should have gotten x equals plus or minus 4.6904. And then for the bottom right, you should have gotten x equals plus or minus 5.3851. We're going to turn the page. All right, for our next one here, we are still rounding to nearest hundredths. My vertical lines didn't turn out so well on this one, so I'll draw some in really quick. There we go. All right, let's do the middle one together. I'm going to subtract 8 on both sides, so we get x squared is equal to 11. I square root, I get x equals plus or minus the square root of 11. So that's x equals plus or minus. I can actually estimate this, right? Because 11 is between 9 and 16. The square root of 9 is 3. The square root of 16 is 4. So this is going to be somewhere in the 3 range, 3 point something. In fact, when you plug it into a calculator, you get 3.3166, plus or minus 3.3166. I want you to try solving the rest of the problems on this page. Pause the video, try it out. All right, you should have gotten x equals plus or minus 2.6457, x equals plus or minus 0.6324, x equals plus or minus 3.3665 for the middle left. For the middle, x equals plus or minus 10.198. For the middle right, you should have gotten plus or minus 5.2915. For the bottom left, you should have gotten x equals plus or minus 7.0710. Bottom middle, plus or minus 3.6055. Bottom right, plus or minus 3.1622. Let's take a look now at some word problems. All right, some real life word problems. How do we deal with them? How do we use this whole square rooting in real life? Well, our first question here, harkens at least a little bit to geometry. Yay, geometry. We have the area of a square is 225 inches squared. Now, a square, we know, looks something like this, right? Draw a picture. And we know the area of it is 225. We want to write a quadratic equation that can be used to find the dimensions of a square. Solve the equation. What are the dimensions? Well, we know that area is going to be length times width. Or another way of saying that would be area equals base times height. But a square is very special because it has all sides are equal, right? All the sides are the same. So that means that this side is going to be x and this side is going to be x. So really our area is going to be x times x. Wait a second now. We know how to do that. That's really x squared if we think back to our chapter 6.1, properties of exponents, right? Our exponent rules. And our area, they told us, was 225. So we have 225 equals x squared. This is a quadratic equation. All right, this is our equation. This is the quadratic equation. To get x by itself, I would have to square root both sides. So I get x equals plus or minus. Well, the square root of 225 is 15. Now here's the thing. The algebra tells us that it's plus or minus 15. But distance, whenever we're measuring something, distance is always positive. All right, distance is always positive. So that means x is going to equal positive 15, or in this case, the sides are 15 inches. All right, not negative 15 inches, positive 15 inches. All right, let's take a look at the skydiver question next. We have a skydiver jumping out of an airplane, and it's given by, I'm going to draw my little airplane up here actually. And then there's that. And then here's my little skydiver dude, and he's jumping out. Something like that. And here's the ground down here. He's jumping out of an airplane, and it's given by h equals negative 16t squared plus 3200. How long will it take the diver to reach the ground? So the how long is asking us to find a time. We want to find the time. Well, if we look at this, we've got h and t. H is going to be the height, and t is going to be the time. That means we want to get time by itself, right? We want to find time by itself. Well, if we want to know how long until he reaches the ground, we want to make sure we don't kill the skydiver, right? That's not the point. Which means that we want his height on the ground. Well, if you're at the ground, how far above the ground are you? You're not, right? So your height on the ground is going to be when h equals 0. So I'm going to plug in 0 is equal to negative 16t squared plus 3200. Let's add 16t squared to both sides. So I get 16t squared is equal to 3200. I need to divide by 16. So we get t squared is equal to 200. And then I have to square root. So I get t equals plus or minus the square root of 200, which is 14.1421. Now think about this. The real world answer is not going to be negative. Negative time would be in the past, right? So the real world answer will be, it takes 14.1421 seconds to reach the ground. Right? 14 0.1421 seconds to reach the ground. That's the real world answer. So we always get a plus or minus, but we have to do that check, right? We have to do that check. So this skydiver is starting at 3,200 feet. Another way of thinking about it. All right, two more questions here. Try these out, see what you get. They're a little bit harder, but I think you're up for the challenge. So the first one here is a touch tank. It has a height of 3 feet and a length of 3 times its width. So 3 feet, and then this right here is going to be 3x. And this is our x. So we know the volume of the tank is 270 cubic feet. 270. Our volume is width times length times height. Well, we know all three of those things. We have our width, it's 3x. We have our length, it's x, and our height is 3. So that means our volume is really 3 times 3 is 9, times x is x squared. So this is our equation. Volume, we just said was 270. So this is 270 equals 9x squared. Well, let's get x by itself. I need to divide 9 on both sides. So we get 30 equals x squared. And then I have to square root. So x equals plus or minus 5.4772. Now let's think about this. Width can't be negative. It just wouldn't make sense if it were negative. So when we plug this in, we know our x is really going to be 5.4772 feet. That's how long it is, which means 3x is going to be 3 times 5.4772. So it's really 16.4317 feet. So that's our real world answer. All right, that's our real world answer. For the next one down here, the area of an equilateral triangle is this, with side length s, is given the formula a equals root 3 over 4 s squared. We want to solve the formula for s. So we've got a equals root 3 over 4 s squared. First thing I want to do is divide both sides by root 3 over 4. Root 3 over 4. So that means I'm really going to multiply by the reciprocal. So I have a times 4 over root 3. These just one out, and I'm left with s squared on the right. So I get 4a over root 3. Wait a second, I do not want to have squared roots in our denominator. I do not want that, so I need to get rid of that. So I'm going to multiply by root 3 over root 3. So this turns into 4a is just visiting root 3 over root 3 times root 3 is 9. The square root of 9 is 3. And that equals s squared. Now I need to square root my s. So I get s equals plus or minus the square root of 4a root 3 over 3. I know it's a little messy, but we're asked to solve it for when a equals 390. So I've got my s equals the square root of 4a root 3 over 3. And I'm going to plug in 390 for my a. So s equals 4 times 390 times root 3 divided by 3. Well, when we do this, we end up with, because I'm just plugging this into a calculator, so we get plus or minus 30.0111. That's the algebra answer. When we actually look at it, again, distance cannot be negative. So that means the side length is 30.0111 inches for that triangle. All right, skills practice is posted. Skills practice is posted. Email me if you have questions. As always.